Lesson 2.5, dividing radicals. Okay, so the division rule of radicals states that the quotient of two radicals can be rewritten as the radical of the quotient. Okay? You must simplify at the beginning, during, and after the division. And here's the big one. The denominator must not have a radical expression for it to be in simplest form. If there is, you must rationalize the denominator. Example 1, radical 4 divided by 4 radical 16. Just like you're used to, we're going to expand out into prime factors each of the radicands. So we have radical 2 times 2, which becomes 2 over radical 2 times 2 times 2 times 2, which 2 of the 2's can come out, giving us 4 times 4 is 16. You can also say to yourself, the square root of 4 is 2, square root of 16 is 4, times the existing 4 to get 16. That reduces down to 1/8. Now here's the other method. If we take radical 4 and radical 16 and we put it under the same radical symbol, a tall, thin radical symbol, we end up with radical 4 over 16. And I hope it's okay that we took the 1/4 out. There's an invisible 1 here, I remind you. So we have 1/4 times radical 4 over 16. 4 over 16 can be reduced to 1/4. So basically we have 1/4 times radical 1 over 4. Radical 1 over 4 can be rewritten as radical 1 divided by radical 4. Each of these are perfect squares. So we have 1/4 times 1/2, which is 1/8. You do number 2. Here we have 3 radical 12 divided by radical 4. Okay? Method 1, factor out the radicands. As you can see, the 2 comes out. 3 times 2 is 6. We have 6 radical 3 over 2. 6 over 2 is 3. Radical 3 stays. So we have 3 radical 3. Method 2, if we rewrite the quotient of radicals as the radical of the fraction, we end up with 3 over 1 times radical 12 over 4. 12 over 4 reduces down to 3 over 1. So in other words, we have 3 over 1 times radical 3 over 1, which reduces and simplifies to 3 radical 3. Let's take a look at I do number 3. Radical 4 over 2 radical 20. So here we have 2 times 2, and 2 times 2 times 5, which is radical 20. We pair them up. The 2 breaks out. We have 2 over 4 radical 5. 2 over 4 can be further reduced to 1 over 2, or we can leave it the way it is, and we can go ahead and rationalize the denominator. And that means we're going to create a perfect square. So the perfect square we're going to create can be achieved by multiplying radical 5 times itself. And this is called rationalizing. So we're going to multiply radical 5 times radical 5 and radical 5 times the numerator in order to keep this fraction the same and equivalent. So we get 2 radical 5 over 4 radical 5 times 5. 5 times 5 is 25, and the square root of 25 is 5. And the 5 comes out and multiplies the 4 to give us this new denominator of 20. Our final step is 2 divided by 20, which is 1/10, leaving us with radical 5 over. Okay, so now we have radical 10 over radical 15. And the first step is to rationalize by multiplying both the numerator and denominator by radical 15, so that we are creating a perfect square in the denominator. And radical 15 times radical 15 is radical 225. Now, instead of writing down 225, I'm going to write it down as radical 15 times 15. And therefore, you will recognize that the 15 will pair up with the 15. One of them dies, the other gets out, and we end up with a denominator of 15. The numerator is radical 150. Now, some people say, let's stop here. This is done. However, the numerator can still be simplified. This radical can be simplified. So we can factor 150 down to its prime factors, 3 times 2 times 5 times 5. And we see that we can extract a 5 out, because 5 times 5 is 25, and the square root of 25 is 5. So now we have 5 radical 6 over 15. And the very last step is to simplify 5 over 15, which is 1/3. And this will be expressed as radical 6 over 3. Last two examples. I do number 5. This is radical 4x expanded out to 2 times 2 times x. And 4 radical 10x to the 4th power is expanded out to 4 times radical 2 times 5 times x, 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 x. As you can see, we paired these up so that the 2 breaks out. And in the denominator, we have 2 of the x's that have come out. So now we have 2 radical x over 4x squared radical 10. And since we have a radical in the denominator, we must rationalize. So when we rationalize, we multiply it by itself. We also have to multiply the numerator by radical 10. And we end up with 2 radical 10x over 4x squared radical 10 times 10. As you can see, one of the 10's come out, the other one does not. It dies, and we end up with 10 times 4 is 40 x squared, and the numerator remains as 2 radical 10x. Reduce the fraction, 2 over 40 is 1/20th, and our final answer is radical 10x over 20x squared. Okay, number 6, the last one. Let's expand it out. 3 times x over 2 times x times x. They're both under radicals. Now we have x radical 3 over x radical 2. We can cancel out the x's. We end up with radical 3 over radical 2, which we must rationalize the denominator. We end up with radical 6 over 2. Good luck to you.